6.5. Solve special types of linear systems. In 6.1, we learned about the consistent independent system, which is a linear system that has exactly one solution. So for the graph of x plus 2y equal to 7, it will intersect the graph of 3x minus 2y at this one point here. So that would be considered one solution. And when we have a consistent dependent system, it's a linear system that has infinitely many solutions. So the system to the right here, for the first equation, the slope is half. The y-intercept is positive 2. So it is the same as the second equation. So the graphs of both of these equations will overlap each other. Therefore, it's infinitely many solutions. And for inconsistent dependent system, it's a linear system that has no solutions. In this case, the slopes are the same. So the slope for both of these equations is negative 3 over 2. So I'm going to summarize this again. For one solution, the lines intersect for the system. And the lines have different slopes. And for a system with no solution, the lines are parallel. And they will have the same slope, but different y-intercept. And for a system with infinitely many solutions, the lines coincide, meaning they overlap each other completely. And then they would definitely have the same slope and the same y-intercept. Guided practice. Solve the linear system by graphing. So for the first system here, I can rewrite this in slope-intercept form. Y equals to negative x minus 2. And I'm going to graph this. I'm going to use a slope-intercept form because it's easier for this case. Okay, shift down 1 unit and then 1 unit to the right. So this negative 2 and this will be 1, negative 3. Okay, and for the second equation here, y equal to negative x plus 5. 1, 2, 3, 4, 5. Shift down 1 unit and 1 unit to the right. As you can see, these two lines don't intersect because they have the same slope and different y-intercepts. Therefore, we can say this system of linear equations has no solution. Okay, and for this next system of linear equations here, I can find the x and y intercepts. So 3x minus 4y equal to 12. 12 divided by positive 3 is 4. So this is the x-intercept. And 12 divided by negative 4 is negative 3. So therefore that's the y-intercept. 1, 2, 3, 4. And 1, 2, 3. Negative 3. Okay, now I'm going to graph the other one using the slope-intercept form. So again, it's also at negative 3. I'm going to shift 3 units up and 4 units to the right. It's the same exact line. So they coincide each other, they overlap each other, so the answer is infinitely many solutions. And for this third case here, 3x minus y equal to negative 9. I'm going to use this x and y intercepts to graph. So negative 9 divided by positive 3 gives me the x-intercept of negative 3. Negative 9 divided by the coefficient of negative 1 gives me the y-intercept of 9. I can go ahead and graph this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 here. I'm going to extend this line. Okay, and for this one, 3x plus 5y equal to negative 15. Negative 15 divided by positive 3 gives me the x-intercept of negative 5, 0. Negative 15 divided by positive 5 gives me the y-intercept of negative 3. So negative 5 and negative 3. So as you can see, the two equations here, they intersect at one point. So we can say that there is one solution. Okay, for this part of the practice, you don't need to identify the coordinate point unless I ask you to. Part B, solve the linear system by substitution or elimination. For this part of the exercise, you can have 3 possible answers as well. Infinitely many solutions, one solution, or no solution. And if you have one solution, you need to identify the coordinate point. So let me show you. Okay, I'm going to see if I can rewrite this equation without a denominator and see what I can do. Multiply this by 2, so this becomes 6x plus 4y equal to negative 5. Aha! This equation happens to be the same exact equation as the first one. So I can immediately say that this system has infinitely many solutions because it's the same exact lines. And for this next one, I'm going to use elimination. But first I'm going to change all the signs here by multiplying by -1. So this will be 4x minus 3y equal to +9. Okay, I'm going to rewrite these equations. 3x plus 4y equal to 12. And then we copy 4x minus 3y equal to 9. And I'm going to use the LCM, least common multiple, between 3 and 4 to rewrite these equations with at least a pair of coefficients that are the same. So I can eliminate a variable to solve for the other variable. So 4 for the first equation and 3. So this will be 12x plus 16y equal to 48. And this will be 12x minus 9y equal to 27. And I'm going to choose to subtract so I can eliminate 12x. Negative negative makes positive, so this is 25y. Negative, positive, negative, so I need to do subtraction here. 48 minus 27 gives me 21, so y equals to 21 over 25. And now I'm going to use the first equation to solve for x by substituting in 21 over 25 for y. So 12 can be rewritten as 300 over 25, and I can subtract 84 over 25. So 3x equals to 216 over 25, and x would equal to 72 over 25. Now I can write my final answer as 72 over 25 over 21 over 25. Okay, for this next one, it's a case where there are no solutions. So I'm going to check to see if they both have the same slope but different y-intercepts. I'm going to take the second equation and I'm going to change it into the slope-intercept form. As you can see, the slopes are the same, but the y-intercepts are different. So this makes the graphs of these lines parallel. And if they're parallel, then there are no solutions because both equations never intersect. And let's prove this by substitution. So I'm going to take 3/5 x plus 5 and set it equal to 3/5 x minus 2. And I can cancel 3/5 x, and 5, as you can see, does not equal -2. So no solution. Part C. Give a counterexample for the following statement. If the graphs of these equations of a linear system have the same slope, then the linear system has no solution. Well, this is not always the case. what if you have two equations such as y equals 3x and 2y equal to 6x? And this second equation would just equal to y equal to 3x. So this system of linear equations would have infinitely many solutions. It's also because they have the same y-intercept as well. Part D. Find values of P, Q, and R that would produce no solutions. So I'm going to first find the slope of the second equation of this system. So my slope for this second equation is 2/3. In order for this system to have no solution, the slope of the first equation also has to be 2/3. So I'm going to rewrite this equation here, px plus qy equal to r. I'll rewrite this in slope-intercept form. So now I can set 2/3 equal to negative p over q. So p can be -2, q can be 3, and r can be 0 or any number. So this is just one possible way to write your solution. P can be +2 and Q can be -3 if you want. An airplane is traveling at a constant average airspeed of 160 miles per hour. The airplane takes 3 hours to travel with the wind from Taipei to Japan. So Taipei to Japan with the wind. I could jot this down in my chart. 3 hours. When you fly with the wind, it would be airspeed plus wind speed. So the airspeed is given 160 miles per hour plus W. We don't know what the wind speed is. And this airplane has to travel against the wind on the return trip. So we can represent that as a minus W. So 160 minus W means against the wind. After 3 hours into the return trip, this airplane is 120 miles from Taipei, meaning when this plane takes off from Japan, and after 3 hours it will be here, and it will need to fly another 120 miles to reach Taipei. So now we're interested in what the distance is here, but we don't know it. It's unknown. So if the total distance is d, I could take d and subtract 120 and write a variable expression to represent that distance traveled after 3 hours from Japan to Taipei. And then from Taipei to Japan, I could just represent the distance as d. Now I can set up my equations. For the first equation, I could take the rate 160 plus W and multiply that by the time 3 and let it equal to D, the distance. And I'm going to simplify this. So this would be 480 plus 3W. Okay, let's set this aside. Let's look at the second equation. 3 times 160 minus W would equal to D minus 120. So 3 times 160 again is 480 minus 3w equals d minus 120. And then I'm going to rewrite this as d equal to 600. I'm adding 120 to 480. This will be 600 minus 3w. Now that I have two equations, d equal to 480 plus 3w and d equal to 600 minus 3w, I can use substitution and set both equations equal to each other and solve for w. This will be 6w, and I'm going to subtract 480 to get 120. W would equal to 20 miles per hour for the wind speed. Well, the problem wants you to find the distance from Taipei to Japan. So we need to take 20. Okay, so we use this equation here. And we need to take 20 and substitute it in for W using one of these equations. So 600 minus 60 would give you 540 miles. So your final answer is 540 miles. This concludes the lesson.